to be for Lab 3, Challenge 1 and 2. To start up Challenge 1, again, all we had to do was create a Cloud Run and use the source code from the index.js and the package.js, which is used here. Through that, then if we can go to edit and deploy, we can check our security, and our service account is right there. And then we can actually go into our container and then into variables and secrets, and see that we have our bucket name, which is our EGR425 Lab 3, and then our collection name, which is sensor data. So if we go into our bucket right here, EGR425 Lab 3, and if we actually click in, just to make sure that it's just not a standard bucket, users, my name, again from the code, and all that text file, so you can download that and check it out. Also, again, if you, for the challenge, you had to use the URL and then paste this at the end of it to see if it got the JSON data, and it does. So that works. And then also if we go to Firestore, we go to default, which you said to label default. We have our sensor data, and here this is just a test field. And then if you go to users 2026, you have all that, which is captured time, user ID, all that. And so that was pretty much it for challenge 1. To set that up, again, use the source code, use the C++ code, and so just through that we had to create a bucket to navigate from that to have the Cloud Run connect to the bucket and the Firestore, along with those variables and stuff like that. And then for challenge 2, we had to get a new version of this, which again, if we go to logs, we can see that again, startup succeeded, time captured, all that. And through that, again, collection name and stuff. And same thing as last time, except it's just doing it to a second screen. And so this main one actually has to do with our VS Code, which we will show here. And again, the embedded systems is going to have 2 screens, which is going to be our local sensor data and then our cloud server data. And so again, we have our include, again, SD card. I don't have an SD card, so I'm not using this. And then we have our flash memory instead, which again, we use this instead of an SD card. And then we have our timing libraries, which we used earlier in the labs for the weathers, and another timing library, which is the Wi-Fi UDP. And then we're using our sensors again always, and then this new library, which allows cloud to be formatted in real time. So that helps. So then we have our URL addresses. So this is the first one. This is the second one. Our variables, again, we want this to be false because we're not using our SD card. Network name, password, ID. Then we initialize our library objects like you did here. And then our actual time variables. And then something new we added here was a time zone offset to display an actual cloud upload time to the local Pacific time. Again, I looked up how to do this, but I do think it is helpful to do that, so it's just not confusing time. And then here's the equation to do that, and thanks to Stack Overflow for helping with that. Then we have to have 2 screens since we're doing that. So this is nothing new. We have our screen states, switching between our normal sensor screen, just like we did before with our local and then our upload one, our cloud. And then we are always starting on local data, and we're never going to be starting on the cloud one. Then variables exist just to hold that JSON data from our good old Firestore. Pretty simple there. Device detail structure. This is stuff you wrote, and then I just copied what you did, but then parsed it with the formatting so it looks nice. And then initializing the devices here, connecting to the Wi-Fi. And then navigating to our actual button C, which when pressing C will take you to the cloud data right here. And then this will actually, when you press button 8, will do the opposite and return you to the normal local sensor data, right? And then this will always display the cloud screen, which is good. And then our sensors, which we definitely need. And then device details, post data. Yep, for the SD card. And then always delaying. And then now we want to show the normal local sensors reading immediately when on startup. So actually, let's get this going while I talk through this. And then, again, this just shows a local message while reading M5 call functions, which, again, is nice for the user, which, again, AI kind of helped me with that because I was thinking of a nicer way. Again, after I do these projects, I do ask AI, I was like, how can I make this a little nicer, a little more comfortable for the user so they're not too distant and not understanding what's happening here. And then now we do an HTTP request for the second URL, which we did with the first. Now we're doing the second one. Just copied that. And then we did the read temperature and humidity from return that from that Firestore document. And then AI I mentioned when I was talking about helping me, it said capturing the time, so that is important too. So we capture the time on our cloud data. And then converting a Firestore to a readable time, which is nice for the user to see, and then captured time and stored time for the original code, which is always good to store in numbers and seconds. And then a new then button C will refresh that cloud data, and then button A will go to that local data. Pretty simple there. And then again, convert the Fahrenheit to the Celsius, which we've talked about before. That just, again, first lab we literally did that, first project. And then this will take in the user ID to help that, and then this will generate the JSON header with all the sensor details and user data to serialize that as the string. And then pretty much it's just the rest of your code here with that SD. And then near the end, again, you just write the same equation as last time to convert those Fahrenheit and Celsius. And then as you can see, it's formatting it. It's attempting to post the data. It's putting it in the Google Storage bucket and the Firestore, which if we can look over here, we go to Firestore, or we can go to buckets first. Cloud storage, buckets, users. As you can see, right here, in real time. So that's really nice to see there. And then if we go to Firestore, we can go to default, and we can also see this working in real time. It's one of these, but yeah, you just see that's 213. The humidity, the temperature, the upload time, the capture, pretty simple there. And yeah, both of those, all of the data is in Fluxing. So this lab helped use prior knowledge with initializing two screens along with converting temperature and sensor data and all that, but it also helped utilize how cloud can connect to our device and give and what we gather on our device can just immediately get put through the cloud using a cloud function, which is a serverless network, but it uses a server function. And so again, we're using Node.js. This is the first one where it uploads it, and this gets the newest one, which is the cloud. So this is the local sensor data, this is the cloud upload time. And so through that, we can combine those, and then you press the button, and it will work. Overall, I think this is very useful. It's very important to transfer an embedded system device onto the cloud, just so you can always retain that information, and we can always have that information accessible to us. Other than that, I think that wraps it up. There will be a separate video demonstrating the device working with a phone, because I cannot videotape that because the cord is too short. Other than that, I thank you.